So in this video, we're going to be looking at the surface area of a cone. I don't think I need to explain what a cone is, but, think about ice cream. Just one of those. Yeah, it's not the best looking one, so let's do. So yeah, let's just take a quick look at some of the key terms that I'm going to be referring to here. That is going to be referred to as the height of the cone from the dead center of the circle to the top, which is the vertex. And from the vertex to the edge. This is called the slant height. And the face at the bottom, like the entire circle, that's going to be called the base. And from the middle to the edge, that is called the radius. So let's look at how we're going to find the surface area of a cone, like we've done other objects and shapes in the previous videos, but this one's a little tricky, or just the understanding of it is a little tricky. You can always just memorize the formula for the surface area of a cone. And yeah, so obviously we have a circle at the bottom here. So when you are looking for the surface area of a cone, you are going to, that's one part of it, the area of a circle. We all remember, area of a circle is pi r squared. It should be pi r squared. But now we also need the formula, or like a way to calculate this part right here, this circular weird part that's small at the top and big at the bottom. We need a way to calculate this. So if you can picture it, or not even picture it, just if we look at like this slanted area, we refer to it as the lateral area of the cone, the part, the side, referring to the side area of the cone, the lateral area. So like this area right here, going all around. So the lateral area that is what we're looking for, and the way we can reason to find a formula to calculate this is by using ratios. So if we look at the circumference, that's horribly written, sorry, of a cone. And divide that by the circumference. basically the ratio that the area of the lateral area of a cone has to the area of a circle is the same ratio that the circumference of a cone has to the circumference of a circle. So if we were to basically use this logic or this ratio, we could basically just plug in that the circumference of a cone is 2 pi r, and the circumference of a circle is 2 pi, let's say, I want to say s, let's use slant height. If we were to basically draw it, it would be like from there, and then the radius here is going to be r, and then we have the area of a circle, it's pi s squared over the area of the lateral. Well, now if we were to simplify this ratio, we have 2 pi cancels out, and we're left with r over s equals lateral area over pi times lateral area over pi s squared. And when we simplify this, we're left with r over s times pi s squared, which is pi r s. I mean, no one's really ever going to ask you to find or like derive this. I did it for fun because I'm a little weird, but if you just remember that the lateral area is equal to pi r s, s being the slant height, r being the radius of the base, and then that's exactly how we will find the total surface area of, that's the circle, and then we have pi r s. So yeah, this is now the formula of our cone. So let's try to do an example. Let's just say we had let's say we had a height of 8 and a radius of 3, and I didn't know what the slant height was, and I wanted to find the surface area, but we absolutely need the slant height, and again, as we learned earlier, easily we could find, in one of the previous videos we used the Pythagorean Theorem to find that out. So in this case, if we look at the cone from the side, a side view, we have 8 here, we have basically we could easily do 8 squared plus 3 squared equals s squared, which is 64 plus 9, s squared equals 73. So s is about 8.5. Yeah. So now we have the radius and the slant height, so we can just plug in 3 pi times 3 times 8.5. And that'll give us about 100 approximately 108. And since we were using centimeters, we're gonna be using cm squared. So yes, that's all I got for this video about the surface area of a cone. I shall see you in the next one.